Hello everyone, let's do this evaluate yourself exercise. Classify the following alcohols as primary, secondary and tertiary and give their IUPAC names. What is a primary alcohol? If a carbon atom bearing the OH group is directly connected to one other carbon atom, then it is called primary alcohol. For example, ethanol is a primary alcohol because the carbon atom bearing the OH group is directly connected to one carbon. Are there exceptions to this? Yes, methanol is an exception in this case. Even though the carbon atom bearing the OH group is not directly connected to any other carbon, because in methanol we have only one carbon atom. However, we still call this as a primary alcohol. This is the only exception. Otherwise, all we need to see is the carbon atom bearing the OH group is connected to how many carbon atoms. If it is connected to one carbon, then it is a primary alcohol. If it is connected to two carbon, then it is secondary alcohol. If it is connected to three carbons, then it is a tertiary alcohol. Let us rewrite the structure given in option A. We have CH3, CH2 and then the carbon hydrogen and then the OH. Whenever something is given in parenthesis, it just means that it is directly connected to the carbon atom. And then CH2 and then CH3, CH3 and then a bromo substituent. Let's number it 1, 2, 3. Here we have to do the numbering left to right so that the alcohol functional group gets the low number. If we do the numbering right to left, in this case, the alcohol will get 4 position. We shouldn't do that, and therefore left to right way of numbering is correct here. We have 6 carbon atoms in the parent chain and therefore it is an hexane 3-ol, but we do have 2 substituents. There is a methyl substituent at 5 position, there is a bromo substituent at 5 position. Between methyl and bromo wins in alphabetical order and therefore that needs to be mentioned first. 5 bromo, 5 methyl and then we have 6 carbon atoms, therefore hexane, and then the position of the alcohol 3-ol. That is the correct IUPAC name for this structure. Now the carbon atom bearing the OH group is directly connected to 2 other carbon atoms and therefore this is a secondary alcohol. Let's work it out the name for structure B. We have 3 ethyl groups connected to a carbon and therefore let us rewrite it this way. CH3, CH2, COH and then CH2, CH3, CH2, CH3. Let's number it. In this case, whichever the way you number it, the alcohol functional group will appear at 3. Therefore, you can choose it either way. And we have an ethyl substituent at 3. Therefore, that needs to be mentioned first. 3 ethyl. We have 5 carbon atoms in the parent chain. Therefore, pentane and then the position of the functional group 3-ol. 3 ethyl pentane 3-ol is the correct IUPAC name for this structure. What about the type? The carbon atom bearing the OH functional group is directly connected to 3 other carbon atoms and therefore this is a tertiary alcohol. Let's move to option C. Let's rewrite the structure. We have CH2 double bond and then carbon chlorine and then CH and then the alcohol functional group and then a methyl group. Let's do the numbering 1, 2, 3, 4. Here we have to do the numbering right to left so that the alcohol functional group gets the low number. Alkene is not the functional group here. Therefore, do not try to do the numbering on the other way around. If you do the numbering on the other way around, then that is wrong. We have a chloro substituent at 3 position. Therefore, 3-chloro-bute because we have 4 carbon atoms in the parent chain, and then 3 in, that is the position of the double bond, 2-ol. That is the correct IUPAC name for this structure. What about the type? The carbon atom bearing the OH functional group is directly connected to 2 other carbon atoms, and therefore this is a secondary alcohol. Let us move to D. Let us rewrite the structure 1, 2, 3, and then the carbon carbon double bond, and then that is 4, and then 5, 6, 7. At 6 position there is bromine, and then at 2 position we have OH. Let us do the numbering 1, 2, 3, 4, 5, 6, 7. We have 7 carbon atoms in the parent chain. We have to do the numbering left to right in this case. We have a bromo substituent at the 6th position, and therefore 6 bromo, and then hept 3 in, 2-ol. This is the IUPAC name without considering the geometrical isomerism here. If we do consider geometrical isomerism in this case, then the hydrogen atoms are opposite to each other, and therefore as per Kahn-Ingold-Prelog rules, that will get the second priority and the carbon atom will get the first priority. Therefore, if you want to mention the IUPAC name by explicitly specifying the geometrical isomerism, then you have to write it as 3E in parenthesis and then the rest. That is the correct IUPAC name specifying the geometrical isomerism here. Now, what type of alcohol it is? The carbon atom bearing the OH group is directly connected to 2 other carbons, and therefore this is a secondary alcohol. Let us move to E. Let us rewrite the structure. We have a phenyl ring, and then carbon, and then the alcohol functional group, and then C2H5 we can expand and write it as CH2CH3, and then another CH2CH3. Here the long continuous carbon chain is this one. It is not this one. Just because it has 6 carbon atoms, that does not mean that it is the long continuous carbon chain. The functional group is in the acyclic chain. It is not in the cyclic chain. Therefore, wherever is the functional group, that is where you need to look at the long continuous carbon chain. Therefore, this is the long continuous carbon chain here. Let us do the numbering. Whichever the way you number, the alcohol will appear at a 3 position. At 3 position, we have the phenyl ring. C6H5 is phenyl. That is what we have here. C6H5, CH2 is benzyl. Therefore, what we have here is phenyl. Therefore, it is 3-phenyl pentane 3-ol. That is the correct IUPAC name for this structure. How about the type? The carbon atom bearing the OH functional group is directly connected to 3 other carbon atoms. Therefore, this is a tertiary alcohol.